Welcome back to Precalculus. I'm going to work a few tangent graph problems just to give you a little bit of extra examples to look at. So let's start off with this one. Y equals 2 tangent pi x over 8. Kind of making this one up as I go. I think this will be a good one though. So what I'm calling the amplitude, it's not really amplitude, but I'm calling it that, is going to be 2. It's that value, the absolute value of that number. And we're going to see what that means on the graph momentarily. The period of this graph, remember period is 2 pi over b, except for tangent it's pi over b, because the formula is normal period over b. So that's going to be actually a really nice value. If you divide by pi over 8, it's like multiplying by the reciprocal. And great news, it's 8. And the reason I like that so much is because our critical distance, if we wanted to find it, would be 2. I'm going to try this without critical distance though, but it would be 2. Mainly critical distance is going to be an issue for sine and cosine, and to a lesser degree secant and cosecant. What else do we need to know? I think we're about ready to graph this thing. So it's not going to shift horizontally or vertically. So let's do that next slide. Okay, so I'm going to draw my x-axis, my y-axis. And so my period is 8. So that means with tangent, half the period halfway to the right and half the period to the left is going to be where your asymptotes are. So they are at x equals 4 and x equals -4. And since the period is 8, if I go another 8, x equals 12, that'd be another period. And halfway between would be what? 8. And then if I go the other direction, 8 more, it'd be x equals -12, and halfway between these would be -8. Okay, that's had technical difficulties there. I think we're back. So I'm not going to label my y-axis. I'm going to just make my graph, make it look nice. Yes, that's what I'm talking about. Yeah, there we go. Usually I'm not quite this good with my tangent graphs, but those are pretty nice. Okay, so that's a pretty good looking tangent. You can tell the period is 8 because the asymptotes are 8 apart. The last thing you want to do is label your y-axis, and here's how you're going to do it. Notice I said the amplitude was it 2? So halfway between my intercept or equilibrium point, kind of halfway point, and halfway between that and my asymptote is going to be 2, right? Halfway from 0 to 4. And that's going to be what I call my amplitude point. Is if you go straight up to hit the graph, that reveals what I'm calling the amplitude, and that is 2 in this case. So there would be another one halfway between 8 and 12, which would be at 10. And you should see that those should line up. They have the same y coordinate. And there would be one over here halfway between -8 and -4, -6. And technically there would be one halfway in here, and it'd be -2, -2, -2. I don't typically label that one. You only have to do one. So let me just change colors here. All you have to do is this one. Just one. And this is what I call the amplitude point. This kind of reveals this vertical stretchiness of the graph. So that's a pretty good graph for y equals 2 tangent pi x over 8. I hope that makes sense. And let's do one more. Next slide. Let's try a horizontal shift. This is simple. We're not going to have much going on here except for the horizontal shift. Let's graph this one. And basically what's going to happen, it's going to shift right pi over 2. Now, yeah, you could do the thing where you set the parenthesis equal to 0 to see where it starts, and that's fine if you want. I think I have room to even graph it on here. So normally there's a vertical asymptote. Let's just do some really light yellow here. Normally we have a vertical asymptote at pi over 2. What else? Negative pi over 2, pi over 2, pi over 2, 3 pi over 2 at the half pi's, right? 5 pi over 2 and so on. But this one's going to be shifted right, so let's get a color you can actually see nicely. How about dark something, whatever this is, dark green. If it's going to everything shifts right pi over 2, then this is now going to be right on the y-axis. And these asymptotes are going to be at 0, pi, 2 pi, and 3 pi, which is actually the same place that cotangent's asymptotes are. Let me try to get rid of this yellow, because we don't need the yellow anymore. Even though it's light, I don't want you to be confused by it. So that's where the asymptotes are. Otherwise it looks the same. So the graph is just going to look simply like this. And really you're only required to do, ooh, that wasn't a very good one. You're only required to do 2 of these, but I'm just going to fill in the space. And you would always want to do the amplitude point. I'll just do that in red again. And the amplitude point is halfway between a 0 point and an asymptote. So that would be, let's see, if this is pi over 2, right, halfway between 0 and pi, this would be 3/4 pi. 3 pi over 4, put a dot, and say, guess what, that must be at 1. Or imagine that you said, oh, I said tangent quantity of x minus pi over 2. I meant to say 9 tangent quantity x minus 2. We say no big deal. Boom. And this thing's done. So your scale really just fits your needs. We're not publishing this to show the growth of sales in some Asian country or something. It doesn't matter. We're just trying to do the task. It doesn't have to be displayable. So you can simply change the scale and you're good to go. So consequently, all our graphs are going to kind of look the same. The main thing that will be different is the scale. So make your scale clear. When you graph tangent, the key thing I'm going to be looking for is the amplitude point. I'm going to want to know what is that y-coordinate, what is the x-coordinate. I'm also going to know what are the position of your asymptotes. And your curve should look pretty good. Shouldn't look like this. It should have a nice smooth curve like this one here. Probably looks the best with this grouping. So anyway, hope that helped. If you want to look ahead to cotangent, you can do that in the book. I'm not going to do one of those here, but you know what? I think I will do a quick cotangent. If you don't want to see a basic intro, you can stop here. I'm going to do a quick intro to cotangent. I have a little time left on this video. Okay, cotangent, real fast. Just the basics of cotangent. Remember, cotangent is the reciprocal of tangent. So where tangent is, let's use that yellow again. Where tangent is 0 and an asymptote, let's go ahead and do tangent on here. Then cotangent being the reciprocal, where tangent has a 0, cotangent has asymptotes. Let's do one more tangent. So this is a purposely, or a really bad tangent, as you can see. So there's also going to be an asymptote there. So if you can see that, we have an asymptote at 0, at pi, and at 2 pi, just like that shifted tangent I did in a previous example. And then when tangent is positive infinity up here, what's cotangent going to be? Well, it's going to be a tiny number down here. Because 1 divided by a really big positive number is a really small positive number. When tangent's negative infinity, like around here, cotangent is going to be a really small negative number around here. And you could do this on and on and on, and you're going to find out the graph is going to look a lot like tangent, but going in the opposite direction. So it has a negative slope. It is always decreasing. So it looks like that, and I guess I could do another one right here. So tangent's always increasing, cotangent's always decreasing. Tangent's asymptotes are on the half pies, cotangent's asymptotes are on the whole pies. So in a sense, it makes cotangent nicer because one of the key things you want to label are your asymptotes, and they're the whole pies. That's nice. We do have an amplitude point with cotangent, similar as before. This 0 here, you can tell it's halfway between 0 and pi, so the zeros are on the half pies, so you do have to deal with that. But halfway between the 0 and the asymptote would be pi over 4. And if you go straight up, we're going to hit our greenish line. That's what we call our amplitude point. Go straight left, the height is 1. And just like before, if someone said, hey, actually I meant to make this 4 cotangent x, you could just do that and say, fine, 4 cotangent x. There's your graph. So hopefully that's not too crowded. We're looking at the greenish lines, dark green for cotangent. But that gives you a little intro to that. Give those examples in the book a try. And we'll be ready to tackle secant and cosecant next. See you next time.